Okay, so let's talk about the basic assumptions of an estimating system a second. So we've got our labor units that we've just looked at. So we looked at a butt weld fitting table, 90-degree elbow or whatever. So the labor unit for that particular item. So what would be the basic assumption of your estimating system? Everybody's estimating system has got to have some basic assumptions wrapped around it. So a good example that I'd give you is, if I'm getting ready to install a 6-inch butt weld 90-degree elbow, am I going to use the same labor unit right here at belt height or 100 foot up a tower? Is it the same unit? No, it can't be, right? Okay, so one of the basic assumptions is that that material has to be installed at a certain height, okay? The WebLEM is 13 or 14 feet is the height at which that material needs to be installed at. So if you're going to be installing it higher than that, you need to apply a correction factor to it. So that's what the basic assumptions are. So when we go out here and we look at the WebLEM, there is the basic assumptions of the WebLEM right here. And then it's just a PDF document. We pull it up and it talks about all of its basic assumptions. Okay, so it's 10 foot. Well, the 13 comes into place. The 13 foot was where the hanger goes. So your 13 was right. You know, it needs to be installed on the first, second, or third floor or the first or second basement. So there are all of the different basic assumptions of this estimating system. And I would highly recommend that you know, everybody go back and read these basic assumptions, because, you know, otherwise you really don't know what our numbers were predicated on, right? So it's very important to know that. I think everybody within their company should know the basic assumptions of their estimating system. Okay, so now let's talk about a labor unit for just a second. I got a box here, and the walls of this box, the outer walls of the box, are the definitions of the basic assumptions of my estimating units. Okay, so they define what this unit is predicated on. So if I were to pull in a labor unit for MCA, the MCA wet labor unit for 4-inch carbon steel butt weld 90 is 4.84 hours. And we look at means as 4.65, PHCC 3.66. So which one of those labor units is right? Come on, we're at an MCA event. You know which one's right, right? They're all right, because what you would do with these is you have to apply a productivity factor to these labor units, your own company's productivity factor. So based on your historical data, these are just a starting point or a baseline for your labor units.
Before you go off that, Ron, one point that I would make, we have looked at the differences between the MCA labor units and means and PHCC, and one of the things we find is a lack of consistency in both means and PHCC. So we start to think that those labor units are developed using historical data and not any kind of empirical method. So that there's a lack of consistency in the other methods that's real evident when you start making comparisons across the board.
So we've got a labor unit that we just looked at, okay, so it's 4.84 hours for this particular weld 90. And then what happens when you now have to install that 100 foot up the tower? That's where the elephant just broke out of the box and says, wait a minute, the labor unit's not inside the box anymore, it's outside the box, because it's now being installed at 100 foot up the tower, or it's in cold weather, or name it, okay, it's made it out of the box. So in order to bring that labor unit back inside the box within the basic assumptions, then we would have to apply a correction factor. Okay, so everybody understand I guess what I'm trying to get across there with the definition of the basic assumptions. So the basic assumptions represent average working conditions assumed to exist at the work site. So, you know, average working conditions meaning, you know, you've got average manpower, I mean, average work temperature, everything about it is kind of like normal or average. And if anything is outside of that, if it's too hot, we need to we need to add a correction factor to that. Okay, so, you know, and it actually says average working conditions must be able to anticipate changes to these conditions when preparing our actual estimates. So, you know, whenever working conditions are not average, we need to apply some type of a factor onto it. This next slide talks about the different locations, being the working locations where we're going to stockpile our material at, the installation, whether it's if it's a surface in the surface conditions, the worker qualifications and the productivity and the material handling. And this all, when you look at the basic assumption document that we brought up a few minutes ago, this is all listed in that document. So if you go back there and read it, you'll be able to see those items. It also talks about special conditions. So, you know, one of the things about joint labor is we get a question quite often. Take a 90-degree elbow versus a street 90. So why is the labor on a street 90 less than what a 90-degree elbow would be that's threaded on both sides? Well, it's because we only consider anything that has a female joint on it. So if it's got a male joint, we don't count the labor for that male side of the joint because it's anticipated it's going to be screwed into a female joint. Spool pieces, we have a hunt and peck on those. So just think about this in a second. If you have a load of pipe that is brought out to the job site and they're just all straight lengths, that's 4-inch in size, the craftsman goes over and he picks up the top piece and he walks away with it. He doesn't have to go through that whole pile finding a specific piece. But with spool pieces, it's different. You need the individual spool that you're looking for. So when you apply hunt and peck, so that's what the hunt and peck factor means. You're going to be over there, you're going to be hunting through the pile. So certain things in the WebLEM have hunt and peck applied to it.
That's a little bit subjective, by the way. Are you likely to have a lot of them, or are they going to be unique in every case? If it's unique, the formula gets a hunt and peck factor, which adjusts the labor unit.
Bolt, nut, and gasket sets, those are already included in the labor units for a flange. So when you take off a flange, you get the bolt up with it. You know, so you don't have to go look that up. Gasketed fittings. So when I was saying a minute ago that everything gets labor on it, there are some things that the labor is included with another item, such as the nut, bolt, and gasket is included with a flange. Another item would be the gaskets, the rubber gaskets for service weight cast iron. That gasket is already included in the joint fit on the fitting itself. So you don't have to labor the gaskets as well, so it's already in there. Some other considerations that you might want to take into account are back-to-back fittings. Now, when we talk about the joint method here, further on into the presentation, the back-to-back fitting thing goes away. But if you're using what I guess I'm going to call the fitting method, the traditional method of taking off a 90-degree elbow, and you're going to weld on a flange right onto the 90 or weld it right onto a T, those are back-to-back fittings. So you need to make sure that you account for that additional labor that's in there, or recognize there's additional labor in there for that you would want to take out of your bid. If you're working somewhere where you got a lot of headers, where you have back-to-back fittings, as opposed to being out on a pipe run where you just got a bunch of long pipe, that's where you would want to make sure that you look and take into account any of those back-to-back fitting scenarios.
The system will automatically, not intentionally, but it just does, you're going to have more joints in your labor count than are really there. So every elbow is going to have 2 joints, every T is going to have 3 joints. If they're back-to-back, the reality is you only have 4 joints, but it's going to count 5. Okay, and that's going to be in your estimate. So that's what Ron's getting at. When you're fitting bound, you really need to take that into consideration.
And then the last thing under special consideration would be footnotes. So just about every table has got a footnote on it. Just make sure that when you're on a table that you read the footnote, because it applies to that table, that particular table that you're on. That's why it's not up in the basic assumptions, because it applies to just that table. A good example of that might be the welding procedure that the table was predicated on.